Today's topic is testing of significance. First is type 1 error and type 2 error. A null hypothesis H0 is tested on the basis of sample values only. For this reason, it has no guarantee that we always take right decision regarding acceptance or rejection of H0. There may occurs two types of error. Two types of error. First one is type 1 error. This error is made when a null hypothesis is rejected, though it was really true. And type 2 error, this error is made when a null hypothesis is accepted though it was really false. Now, probability of type 1 error. Let H0 where theta is equals to theta 0 be a null hypothesis and T be the test statistic. Now, the probability of type 1 error is equals to probability of rejection of H0 theta is equals to theta 0 on the hypothesis that H0 is true. That means this is probability of computed value of T lies in critical region CR where theta is equals to theta 0 is true. This is conditional probability. Okay, so which equals to the level of significance of the test, that is equal to alpha. This is called size of type 1 error. Now, probability of type 2 error. Let H0 theta is equals to theta 0 be a null hypothesis and T be the test statistic. Then the probability of type 2 error is equals to probability of acceptance of H0 where theta is equals to theta 0 on the hypothesis that theta not equals to theta 0. Okay. So if we assumes that theta is equals to theta 1, then probability of type 2 error is equals to probability of computed value of t falls in the region of acceptance where theta is equals to theta 1. Okay. Next, best critical region. Let H0 where theta is equals to theta 0 be the null hypothesis. Which is to be tested by the test statistic T and H1 be the alternative hypothesis. Then the test is depend on the choice of a region of acceptance or critical region, that is CR. It would be good if we can select a critical region so as to minimize the type 1 and type 2 error. This is not so simple because one type of error is accompanied by an increase of other type of error. So to obtain the best critical region or region of acceptance, corresponding to the level of significance alpha such that the probability of type 1 error relative to CR is alpha. That means probability of computed value of T lies in CR, assuming theta is equals to theta 0 is equals to alpha. So there may exist so many CR, but among these that critical region is best for which type 2 error is least. Okay. Now, power of a test. Here, the goodness of test depends on the choice of CR, as the probability of type 2 error decreases, the goodness of the test increases. So, power of a test is equals to 1 minus probability of type 2 error, assuming H1, that is alternative hypothesis. So, if the best seer can be selected, the power of test becomes highest. example, in order to test whether a coin is perfect, the coin is tossed 5 times. The null hypothesis of perfectness is rejected if more than 4 heads are obtained. What is the probability of type 1 error? And find the probability of type 2 error when the corresponding probability of head is 0.2. Let P be the proportion of the number of head among 5 times of throw. The coin is perfect if P is equals to half. Since the probability of head for a perfect coin is half, so the null hypothesis is H0, that is P is equals to half. Now H0 is rejected if the number of heads greater than 4. So it is now probability of F greater than 4. This is right, F. Okay, probability of F greater than now probability of F is equals to R. This is equals to probability of R heads in 5 tosses, that is equals to 5 CR P to the power R into 1 minus P to the power of 5 minus R. Here F is 5P binomial variate. Okay, so the probability of type 1 error is equals to probability of rejection of H0 on the hypothesis that H0 P is equals to half is true. So this is equals to probability of F is equals to 5 on the hypothesis P is equals to half, that is 5C5 half to the power 5 into 1 minus half to the power of 5 minus 5, that is 1 by 32. Now probability of type 2 error when P is equals to 0.2, that is probability of acceptance of H0 assuming P is equals to 0.2, that is probability of F less than is equals to 4. Assuming P is equals to 0.2, so it is 1 minus probability of F is equals to 5. Okay, that means assuming P is equals to 0.2, which is equals to 1 minus 5C5 0.2 to the power 5, 1 minus 0.2 to the power 5 minus 5, that is 0.99968. This is the probability of type 2 error. Okay, there are so many examples in the books. You can go through it.